Attana is a company based in Stockholm, Sweden, and we are developing and marketing biosensors for studies of biomolecular interactions. And we are applying a technique called the quartz microbalance technology for that, and it's based on the piezoelectric effect of a quartz crystal. And we are currently focusing very much on delivering biologically relevant data to this community. And we are specializing in the possibilities to perform interaction studies also in the background of crude samples and non-specific molecules, and also in the possibility to make the interactions directly on intact cells. We are here in Boston with our latest instrument in this field, the Attana 200, which is an instrument that's specially suited for this kind of analysis in crude samples, for instance, and it can do kinetics, off-rate screening and selection of different antibodies. In this following video, we're going to look at how a biological interaction analysis can look like in this cartoon setup. Look at one example, one application example, namely the characterization of a monoclonal antibody. And here you see the antibodies flowing in and get immobilized, so they are covalently linked to the sensor surface. And since this is an antibody, it will interact with an antigen, which is coming in here and binds to the antibody. And we can measure how fast it binds to the antibody and how it dissociates from the antibody. And that's the kind of fundamental of this technology. And what you see here is that we add an agent that denaturing the antigen so it can be removed from the surface, re-establish the surface binding capacity to what it was before the binding. And you can get a readout from that, what we call a sensorgram. And then you repeat this interaction analysis. So here it's antigen at the medium concentration, and you look at the binding at several different concentrations. And look at the binding and the dissociation of the antigen from the antibody. And between each interaction analysis, you regenerate the surface to its initial capacity. So then when you have performed your analysis of the binding between the antigen and the antibody at different concentrations, you will have your final data, which you then use a global fitting algorithm on in order to determine the binding and dissociation rates for this interaction. And from that you can get the affinity. And this would help you to give an idea of the characteristics of the antibody, how well it binds to its antigen and how well it performs.